Well, let's start. I hope there's no one else that we're expecting, so probably just give me a minute or so. We should be good to go. I believe we still have a minute left to start, so just give me a minute, so we'll be ready to go after that. All right, so we can start. Uh, so I would like to give you an insight or just an overview of what we do. At SFJ, we've been delivering trainings, extensive amount of trainings with respect to various set of domains and technologies, starting from the conventional databases to the high-end technologies, whether that is artificial intelligence, robotics, IoT, that cloud computing, or the mobile technologies, and obviously then the skill-based trainings, that is with respect to the virtualization, the latest trends in the market, standing up with the exploring around the things that have been moving the market lately, whether that is with respect to machine learning, analytics, predictive analytics, streaming, big data, and obviously the conventional technologies like web applications, building web applications with synchronous or asynchronous programming languages like Java, Akka frameworks, Scala, .NET, most other open source technologies like Node, and the rest of the UI flavors that exist in the market. So in name a technology, there will be a specialized trainer and an expert individual at SFJ who will be delivering the best out of it at around the day across the globe. We have been in the industry for quite a long time now, so it's probably close to less than a decade yet, even though it's around 7 or 8. It's probably the 8th year of our existence now. Even though the team is not really that big, but because we try to make sure that whatever we are doing, that is always in the crisp and more qualitative. Not We don't really run around with the quantity. We mostly ensure that what we're doing is the best in the industry, and we are making an impact on the industry. That has always been our vision. That's how SFJ was started. We work with most of the big Fortune 500 organizations or enterprises, and you name the alliances or the associations, regardless of which technology we are working. So we will have one or the other association with most of our corporates. We have delivered more close to around probably more than 500 uh, WebEx or online trainings, whether that's in India or abroad or overseas. We have a physical and virtual presence across the globe, probably around 25, 26 odd countries now at present, and most of the Western market or the European market, we will be doing something here and there, primarily around the virtual side. But if we talk about the Asian market, we've been delivering a lot of trainings with respect to whether that's a formalized course or the public batches or some specialized trainings with respect to specific set of technologies. We will be definitely joining and ensuring that we're delivering the best. That has been the prime focus of SFJ since its inception, and we're trying to ensure that we continue to do the same with respect to regardless whoever is taking who is getting on board, and we try to ensure and stand by our motto and goals. That's what primarily SFJ is for. Well, now focusing more on the agenda and the overall course that we had planned for our public batch for IoT, what we will cover in that, and what we will cover today in this current session of this 60 minutes. But before that, I would like to give you a brief introduction about me. My name is Mosem. I have been in the industry for a very long time now, more than a decade now, even though I'm not really that old. But I have done a fair bit of work in the industry. I have worked with a lot of enterprises. You name most of the Fortune 500, where you start from Hewlett Packards to probably some of Google. I do. I've been a full-time associate. I have worked on a lot of technologies, starting from the conventional Java programming to the extended version of Python or R. Or if we talk about the emerging technologies, whether that's on the big data side, whether that is on with respect to the data structures, DSN algos, or if we talk about working on the architectural side across the full stack ecosystem that has been booming in the industry, or the AI or robotics. I must have explored, and I must have delivered one or the other project around these domains. In the IoT specifically, I have been doing a lot of projects. Obviously, there have been some very big projects that I've worked with, wherein the team has been starting from just 10 members to probably around 100 odd members on the development side that I work, the projects that I've built with, starting from uh, conventional manufacturing, because manufacturing has always been the biggest consumer or the biggest player in the IoT domain. So most of my projects have been around IoT domain, but some few of them have been in the consumers or consumers ecosystem, whether that is with respect to smart electronics or smart cities. So there are a few of the projects that are still ongoing that I've been working on. On the training side, I have been giving public lectures. I have my own portal. I have few public speaking courses that I deliver occasionally across the globe. Few of them in SFO. There are a few that I have delivered and that I'm planning to deliver, and few of them are actually on IoT in Great Britain, uh, probably starting off next month. So I enjoy technologies. I do a lot of exploration. I dedicate a lot of time towards hands-on, and I like to share my knowledge and experience and expertise in my core areas with respect to my knowledge with people around me. I enjoy that, and I always try to learn more. That has always been my key. So that's mostly about me. With respect to the agenda for today, we will be mostly talking about what exactly IoT refers to, what all things do we have in IoT, how how the market around IoT goes around or looks like, what all the things or what are the major players in IoT domain, and how has the IoT boom actually affected the industry, or which all industries have been affected primarily, and which of the industries have been the least affected because of IoT. What are the hottest skills? What are the skills we actually require with respect to IoT? And what are the actual hottest skills that the industry is actually looking for these days, when we look from a job perspective, from a working exposure with respect to the real-time systems, how IoT will be expected with respect to the growth, if we talk from a growth perspective, because if you see how IoT was accepted in the industry 5 years ago or 10 years ago, the transition has been there has been a huge leap from where IoT was 5 years ago and where IoT is right now. And if we talk about the forecasting from in the near future, probably the percentage of growth is immaculate. It's probably in thousands of persons that we will be expecting in IoT domain. So we'll talk about probably a brief about that, how the growth chart really looks like. We'll have an insight of what are the various components in IoT, what exactly comprises of IoT, what all things do we have in IoT. Probably we might talk about some basic components on the IoT stack, what all things we have on the IoT stack that we really use more commonly, and what component fits at what place of the stack, and then probably some of the bigger major players that we have in the IoT market, whether we talk about Azure, AWS, Siemens, IBM's Watson, uh, or the thing works. So we'll be even though we'll mostly focus on Azure and AWS, but there are some other players as well. Considering who have been delivering their services for IoT as a service to onboard and to simplify how we will ensure and how we will leverage the best out of the IoT industry. And we'll go through an overall architecture of the components that we have in place. I might walk you through a couple of commonly used cases with respect to the industry overviews. We might go. So in the end, I would like to go through uh, the overall the overall architecture, or probably some common components in uh, from the AWS or the Azure console, to give you an insight of how these platforms depict the IoT ecosystem for us. Well, that's all what we have on today's agenda. So in case any of you have any doubts, feel free to ask. All right, seem none. Well, the agenda that I just walked you through is what we'll be covering today. With respect to the overall agenda, to just to just give you a snapshot of what we'll be covering is that's what it's being mentioned here. An overview of we'll walk you through an overview of Python. So since most of the connectors, most of the integrations with respect to devices do or use a lot of Python or C++. So we need to have an overview of them. That's what we will cover, just an overview. We might not be covering all of those things in the 30 hours of duration for the overall course. So, but we would like to cover the things that are very necessary. We will explore our sensors, what all kinds of sensors we have. We talk about the heat sensors, we talk about the temperature sensors, we talk about the motion sensors, and the kind of data that we can gather out of them. We might go through some real-time examples as well, connecting some physical sensors to our systems, and then probably accumulating the data out of those sensors. Obviously, most of the times, if you talk about, if you go through any of the IoT courses, or if you try to learn IoT at home, the best way to do that or explore that is use some commonly used hardwares like the popular heat sensors, as I mentioned, or the microcontrollers, whether that's Raspberry Pi or any other microcontroller for that perspective, that we can onboard and connect very easily. We can have our set of softwares deployed on that, and then probably explore how the communication happens, how we send an information or how we send a signal to the hardware for performing an explicit XYZ activity, or how we can disable that operation on that from our system on that specific hardware. We'll have a walkthrough of that as well. We will explore how to onboard assets, or what we call as devices, on the cloud platforms, whether that's AWS or that's Azure. The components that we have in Azure, well, that's the Event Hub, the IoT Gateway, or the Event Grid, or on the contrast, if we explore the components that we have on AWS, whether that's Greengrass, or that's RTOS, or that's the IoT core. So we'll try to get more and more, as much of hands-on as possible on those components, and try to understand how we can benefit out of them, then to build something from scratch on our own. The data, the ones we will get on that, will try to generate some analytics, mostly some predictive analytics, to give you an insight of how that data that we are pushing from the devices on our gateway or on our system, how we can leverage some useful information out of that, and how will that make sense. The second is the second important functionality in IoT is the security. Now we have the device, how we ensure the device is being secured. No one else is actually stealing data out of it. No other's gateway is trying to access or interact with that device and get some or steal the data in either perspective, to ensure that we don't have a security loophole on the device side or on the gateway side. That's where the various mechanisms, various layers of securities come in place. So there's a different security mechanism on the device side, on the asset, and there will be a completely altogether security mechanism that will apply on the gateway side. And either of them, so in since with respect to devices, we cannot rely only on one security system. So we will find that there will be a various set of security systems that we will be exploring. Well, that's what we have in the agenda for the overall course. If we talk about the end-to-end outline, that is what's it's like. It's more of, even though you might you can get the detail through any of our coordinators, they can share. I'm sure that you must already have that. This is just to give you an insight, a high level insight of what all things we'll be covering in the end-to-end outline. All right. So, well, starting on the today's discussion, moving ahead, the IoT, as you all know, I'm sure most of you are already aware that IoT stands for Internet of Things. Now, even though the IoT has been there in the industry for close to 2 decades now, as you can see, I mean, we had probably around in 99, or I would say around 2000. That was the correct time when the Y2K boom actually came in, and IT started to grow up with respect to the systems, how people interact with how people leverage the best out of information technology, and how we can ensure that the machines that we have, or the equipments, the hardwares that we have, are being used optimally as well. So to build a connection, to build more usability with respect from a system to a human, from a system to a machine, or from a machine to another machine. Now that was the first step towards the IoT ecosystem, or the inception. That's where the actual inception actually started on. Even though there have been some uh, prior prior explorations around this domain, wherein the inception of M2M actually started. Not really Internet of Things, but more on the M2M side, wherein a machine was able to interact with any other machine based on the kind of information, or based on some specific data inputs or data items that were actually pushed in, or that were actually shared across those two components. Now, that is where the machine was actually shared, and so now both of them. both of those entities were actually being pushed in. Now, the thing was that the M2M has been in the industry for actually even before the Y2K boom. But the problem with that, with respect to M2M, was that it was very confined. So we're not really able to utilize it on a broader scale. How we get the information out of those machines now. Now, if we want to go to the next level, what is the next level? So that was still an open question. That is the problem that IoT actually was trying to solve off. Now we have everything on the internet now. Everyone or every machine or every human being is connected to the internet now, or every device is connected to the internet now. How we make sure that we're able to coordinate to each other, how we ensure that the data that we get from one machine or one device can decide how device 2 or device 3 will behave, or how that device 3 will respond. Now, to do the integration, to do the interaction, that was the first phase of IoT. Even though it became very, very confined and it became very restricted to very explicit domains, most of these transitions around this, around the IoT, on and around IoT, primarily happened we jumped around when we jumped with respect to the manufacturing domain predominantly, and some part of healthcare. Now, these were the two major domains wherein IoT actually started from. But the rest of the domains were mostly confined, they were restricted, so you couldn't find, or you couldn't actually really do much of the information. Now, the biggest challenge and the biggest reason why it actually became very restricted to mostly the higher configured systems, or more configured systems or large systems, was because the transition or the transformation that IT, the information technology, the devices went through in the past decade has been enormous, and there is no comparison and there is no expectation of such transition that have happened in the past 10 years that we could have expected in probably around in 2000 or 2001. So that is how. Now, see, I am not really sure that we could have expected that we will have a smartphone that can do n number of things that will help us to that will actually help us to manage or configure our home appliances right now. uh, Something, imagining something like this probably 15 years ago might have been different. So it could have been it was almost impossible to do something like that. Now, that is the reason why there was a completely new there was a completely new expectation, and there was a completely new transition that that has gone through in this current. Now, now the I mean, it's more of actually the same thing as I was saying. I mean, what exactly IoT is now. Now, in the simplest terms, what actually defines IoT? Now, IoT in the simplest form is just the connection of devices, primarily the devices that are primarily connected to the internet, directly or indirectly, and they're able to communicate. So so if we have multiple devices, for example, if we have a phone, in the simplest perspective, that can be connected or that is connected to the internet somehow, that's a connected line through the SIM card or through any of the open networks. So now that device is generating some information, regardless whether that information is valuable or invaluable, and that information is being sent or is being communicated to some other device, to some other phone. For example, we're using a WhatsApp, we're using Facebook from our phone, and that's connected to probably some other phone, someone else. There's another individual in some other place in the world who is trying to interact with that device that's responding, that's sending some specific information, probably some MAC address of that phone to some other person, or that is sending some additional information with respect to that. Now, this is a vague representation of IoT in the simplest forms. Now, in this perspective, the first thing that actually happened is that two devices were connected, maybe two phones, or probably a phone with a laptop or a computer. So now in both the perspectives, we have two devices who are communicating or who are interacting with each other. Now, the problem in this is that most of the things are actually being done by the software. So most of the things are actually done by WhatsApp. It's not really the device that's actually doing something. So that might not actually give us the extensive amount of information, but it is still giving us information. Now, this is first form of possibility. This is one form of IoT. Now, this is the major section of IoT, wherein we are actually generating, or wherein we are actually getting some major chunk of information. Now, based on this, what's from if we have WhatsApp, we'll be able to get uh, uh, later on we'll be able to get the we'll be able to get that information and an idea with respect to how that actually is useful, how that individual responds, and what kind of uh, responses or what kind of informations that IoT is actually doing it. Now, this is the simplest form of IoT. Now, a broader perspective can go to, for example, smart cars. A car is driving on the road. Now, the manufacturer wants to get the information about that this car is actually due for service 15 days from today. So now we get the car owners, or the individual who owns the car, who possesses or who's actually driving the car, gets the information, gets the notification that this car is actually due for service on XYZ period. And the closest service center is probably 10 miles away. So now that's another possibility of, or that's another use case of IoT. Where exactly IoT stands in. Now, this in a broader perspective, I can say that this is actually IoT. Now, in the simplest terms, now if we go a step back again, just like I was saying about the phone. Now, if if a phone is sent some explicit information about himself, if a phone is sending some explicit information about himself to another phone, right, that is the optimal expectation of IoT. So now this is the first introductory step of IoT, that wherein IoT actually started getting into picture. Now, IoT started. This is in the IoT system or IoT ecosystem. This connection, sending personal information from one device to another device, or from one machine to another machine, was referred to as M2M, machine to machine communication or coordination. So they are sending some personal information to each other. Now, that was the first step of IoT. And then probably it went on to another set of machines. Now, IoT has gone broader than conventional internet-based devices, internet-based systems. Now, the IoT is not reliant, or IoT is not just confined towards the devices that communicate or that always talk over the internet. Now, there are different forms of networks. So we can have any communication protocol across devices that we can use to fetch in the information, to pull out the information from a specific device and then decide what to do with that, or probably push information from one device to another device to decide what to do actually with that information in from device to. Now, just like I mentioned, that the first thing the first thing that actually came into place was M2M. So now these are some standard common terms that you will find, that you will come across if you start exploring what exactly IoT is. So there will be a wide range of terms, a wide range of things that people talk about that actually come into mind, that okay, IoT is a broader perspective. We understand now how exactly the communications happen with respect to in this broader area. It's like IoT is like an ocean. So now we have to understand what are the exterior streams that actually flow into IoT, or probably that carve out of this specific ocean. So now we understand that the first introductions came from the two devices or across devices. That's where the M2M came into place. Then the Internet of Everything. Now, the Internet of Everything was mostly with respect to when we are expecting only those devices that have internet connected to, or we're expecting that all the devices that are useful will always be on the internet. They will always be connected to the internet somehow. Now, that communication, that interaction might or can always vary. So, for example, the phone is more useful because we can get the information of the phone from anywhere in the world at any point of time. So, it's more relevant, it's more useful, and it's more powerful than probably as a disconnected device than a comp at the simple or the basic comp that I have at my home. So it might, or a simple pen that I have at my home. So now that's where the Internet of Everything actually came into place. Now the Internet of Goods, it was mostly explicit towards in the FMCG areas, the commonly sold or purchased consumer goods. If you go to Walmart or if you go to Costco, so we have all kinds of items in there. Or if we talk about the supply chain, so there's a wide range of items that we are sending in, or they are coming in from one place to another. Now those devices, so now if we go to a Walmart store that's so large, and there are thousands and thousands of items, and then probably they have been categorized and they've been organized. So now if you ask a specific individual what exactly that item is, he goes and he checks that off, and he guides you probably the this form of item is probably in this alley, and then probably inside that he will tell you that probably this branded item is probably on that shelf. So they organized it in that perspective, so as we'll be able to. Now if an item is missing, to manage the inventory, so what they do is probably they might use, for simplicity, something like RFID or the barcodes. So when we go to the seller at that point of time at the cashier's counter, he might probably track that item using a barcode. Based on that, he will be able to know that how many probably X to probably a 1 to 10 barcodes in this range are on shelf 1, barcodes from 10 to 11 to 20 are on shelf 2, and then probably barcodes from 20 to 100 are probably in the warehouse. So that's where the Internet of Goods and actually the industrial internet actually comes in place. Now, even though industrial internet is a little broader, mostly perspective with respect to the higher machines. If we talk about hydraulic engines, or if we talk about ships that are giving us some information that okay, this is the current location of the ship. Now, a ship is going for a voyage. At this point of time, there are 10,000 different kinds of hardwares that are associated with that ship. Now, to get a broader picture of at what point of time will a service we do, or probably if we can have, if there's a possibility of a breakdown, in that ship at that specific point of time. That is where the industrial internet comes in place, and some part of the wireless sensors. That's where you might actually talk about those kind of things with respect to that. The smart objects is mostly with respect to, and digital twins. You will find those things more adhering towards the smart cities, wherein, for example, we have the automated lights as soon as we walk on that site. So the light actually turns on, or probably we can access that light from our home using our phone, and then we might decide at what point of time what is the usable, how many number of units is that light burning off in the morning or in the evening, so we can decide how frequently, or probably what voltage should that bulb have in the morning, and what voltage should that bulb have. So probably we can have smart bulbs that decide. Probably a bulb might not be extensively useful during the day, but as soon as it crosses probably 5 or 6 in the evenings, we know it would be more useful. But from 5 to 10, it might not be extensively useful as compared to from 10 to probably 5 or 6 in the morning. So because in the nighttime, the lesser people, so we can decide those kind of things. That's where the smart objects and the digital twins come in place. Okay, so now, just as I was mentioning that, now what are the actual applicable areas where IoT actually becomes useful and IoT is really helpful, that is giving more simplified way of the lifestyle, or that is actually giving a more optimal way of how the machines or how the devices around us, or how we are dealing with the society. Now there are different domains, and there's a huge range of market where an IoT is actually working right now, and there has been a lot of impact, and there has been a lot of change in the markets with respect to the IoT domain, if we talk. But if we talk with respect to the consumers and the industrial, they have been the major players, obviously, because most of them have, because the consumer is the daily goods. For example, if we talk about the cars or smart homes or the smart appliances in our home, or if we talk about the smart watches, the health trackers, the health monitors, uh, the smart devices that we have at home, whether talk about the electrical units or the electrical appliances, smart electrical appliances. So those things have grown extensively in these years. In the recent, probably I would say in the past less than 5 years, that's where consumer consumer domain has extensively grown, has immensely grown. Then we have, with respect to, you will find a lot of transitions going on, the industrials, large scale industries, wherein there's people, wherein the equipments are actually getting manufactured, or probably if we talk about the robotics, that's where that's where the artificial intelligence, or the RPA, or the simple robotics actually have a major role to play in there. Now, most of the times you will find that when you move on to the artificial intelligence, the IoT plays a very important and very valuable role in there, primarily in the industrial domain, because most of the devices, when they actually go, if we have if we talk about explicitly in the manufacturing domain, or in the broader perspective of the industrial areas, or in the industrial ecosystem, so you will find that there are various kinds of devices that we use, and how we're actually trying to simplify the way, or how we are actually trying to optimize the way we're doing. For example, I will give you a very simple example. Let's say in the earlier times, we actually used to uh, manually identify how many parts are there, how many parts are actually being used. If a part is actually broken, then identify and categorize them while building a car. But now those things have actually got automated. So every item, probably there is a health check, depending, obviously there are different kinds of sensors every item can have. And then probably with respect to the artificial intelligence, what we can do is we can identify that what is the percentage of breakage in this section of the items, and then probably based on that we can decide that these are the most commonly broken items. For example, a set of screws in a car that we use in the doors or in the windows, or probably glass that breaks off very quickly. So we can identify that using the artificial intelligence. And then with respect to the IoT, we're able to get the information. So we push the information to an artificial intelligence system using IoT, and then the artificial intelligence system decides or responds on top of that. So you find a very, very good connection in between IoT and artificial intelligence. Even though this is not the right time to discuss more on that, so I won't really jump much on the artificial intelligence side. So we'll try to keep our focus more on the IoT side. Similarly, will have a lot of impacts with respect to the commercial systems, with respect to the power grids, the automation of the power grids, the water systems, the sewage systems, how they are getting automated, or how how the healthcare system is actually getting simplified. If we talk about the CT scans, if you talk about the PET scans, or most of the X-rays or the scanning devices, and how one with respect to how we can remotely access them, that is one form of IoT. And the another form is that at what point of time we know that this specific machine requires a repair, or which item of this machine is actually entitled for repair. So becoming more explicit, becoming more specific towards a specific item. That's where IoT becomes more useful. It simplifies the existing systems that we have in place. It simplifies, it gives more useful meaning to the existing machines that we have been using on and around us, and that we are still using on and around us. Now, with respect to the popular use cases, if we talk about that, what are the popular use cases? So we have a lot of use cases with respect to the automation, just like I was saying, the smart systems at smart homes, or if we talk about smart watches, or smart bands, or if we talk about the lighting, the automations of the heatings, the popular sensors, various kinds of sensors that we have, or the connected cars, accessing the most of the popular things that we can access in a car from just a click of our phone, or remote access for those devices inside our car, or the various set of equipments. In the industrial side, just like I was mentioning with respect to the car or the healthcare, so we will have a lot of things with respect to predictive maintenance. So we can predict that at this point of time there might be a tear down in a specific machine, or at specific time there is a possibility that a specific equipment or a specific hardware might fail or might not be able to respond, or at specific point of time we need to have oil refills inside a specific machine. So there can be various use cases with respect to the industrial world. So you will find larger and bigger most of the use cases around the industrial one and the commercial one these days. In the commercial one, just like I was mentioning with respect to the healthcare, so there's a wide range of sensors that are being embedded in the popular or the most commonly used healthcare equipments or hardwares. Since the cost gets very high, so proper maintenance and accurate usability of those systems or those machines becomes more and more important. If $1 million machine gets broken down every now and then, and you have to go and you have to repair it, then it becomes very cost ineffective for the user. So a subscriber always tries to ensure. And then now if an individual comes and it takes him days and days to shut down the machine and then probably explore what is the exact problem to identify that, wouldn't it be more easier if we are getting the frequent inputs out of that machine that gives us the health information about that machine, how exactly that machine is responding, and if there's a breakdown, we know exactly what are the possible cases. So there's a more refined possible area of that breakdown. That's where the IoT can become more useful. With respect to the smart cities, so you will have the smarter parking, smart street lights, the managing of the pollution with respect to smarter business units, or if we talk about more smarter waste disposals. Now, those are some of the common areas wherein we will be able to explore and will be able to will be able to get leverage the best out of IoT. Now, if we talk about the connected devices, the percentage, the growth of the devices, how that the transition has actually moved on. If we start from a couple of years, if we just go a few years back, so the percentage, the amount of devices that have actually onboarded, that have become part of the IoT market. So you can see the rise of the growth of the percentage. Now, if you see the percentage where we actually stand right now, so the index at which we actually stand right now, based in with respect to the number of billions. Now, if you see what is the growth rate, how many of the devices get onboarded on the IoT systems in the next 5 to 6 years, so it's probably around 21 odd billion devices that would get onboarded on the IoT systems. Now, imagine how much of work and how much of stable these systems need to be, how much of information will these systems generate, how much of job opportunities and job flexibilities does this have, and how much of exploration and how much of more information does it give us with respect to the growth in this domain. That is a more interesting and that is a more exciting thing about IoT. With respect to the market growth, as I mentioned, that it's expected to be close to $2 trillion by upcoming year or so, with respect to which we'll be expecting a huge impact of IoT. Since now, if we have so many billions of devices connected on the onboarded in a specific ecosystem, obviously there will be a lot of revenue around on or around that ecosystem that will actually eventually drive the rest of the things around it. With respect to the market share, manufacturing is a major leader, it's a prime leader, and healthcare has grown. So the percentage has grown. Earlier it was probably around 12 to 13. Now it has grown on to 16 to 20. So you will find probably 40% of the growth is probably around manufacturing and healthcare. Yes, I mean, so okay, so seems it's a question. So, so we can check on this. All right. Now, with respect to the set of devices, as I was mentioning, so probably it's around close to 24 odd billion devices that we have. How much money that we are actually pushing in, how much of information that we're actually getting inside in here, what all domains that we have, what is the percentage of organizations or enterprises that are jumping into this. So if you see now, with respect to the common set of the commonly used systems or commonly used machines have more information with respect to with respect to this domain. So that's why home is growing a lot, because people tend to. So that's why you will find a lot of things. So if you see that Amazon's Alexa or Google's smart devices, so you will find a lot of those things. So they will eventually pull up that information around that. So that's why you will find the home, or if you see the information, the kind of information that is being onboarded on Facebook, on WhatsApp, with just few billion people, and then how many millions of records and trillions and billions of inputs people put in, based on which Facebook knows how a specific trend is going on, using machine learning and artificial intelligence. That is another form of IoT, as I was saying. That's where people actually tend to drive in that, right? So, with respect to the skills, as I was saying, so there are a lot of skills that have grown off. There has been an extensive, rapid increase with respect to the skills that have extensively grown. Obviously, machine learning has been the prime leader, because now we are in the industry wherein we already have devices. We are trying to onboard more and more devices. One, second, now when we have devices, they are talking to other devices, or they are talking to other people, or people are talking to people. So that means there is more and more data that is going on. Now if we have more and more data, that means we are actually growing more useful, and we are getting much more information. So that's where we now, once we have data, so that means most of the analysis and R&D is actually being explored. That's why machine learning is the prime leader. Then we have the nodes. Node is mostly because to simplify how we build our applications. But if you see, with respect to building our systems, with respect to the how we are interacting with the data, how we are pulling the data, how we're pushing the data, now see, most of these skills are the prime leaders, or are the prime providers, or prime players in the IoT domain. With respect to the job market, how the industry is actually going on, obviously there has been an extensive expectation of Python. There's an extensive usage of C++ with respect to the devices, the integration of the devices and onboarding of those devices. That's something that goes on extensively. And then probably there is a wide range of roles with respect to big data, data science, artificial intelligence, or analytics. That's another domain wherein you will find a lot of work around that. And then we have the rest of the other components, or other tools that we can talk about. Now, with respect to the technology drivers, so there's a wide range of technologies, but I see that the time is very less, so we won't talk. So I think we can just. So there is a wide range of. Sure. All right. So I think we are already over the time. So, but let's take 5 or 10 minutes more. So before we end the session. So as I was saying, that with respect to the major components of IoT. Now, see, most of the times, the first and the foremost important thing in IoT is the device, what we refer to as a device or an asset that we talk about. The next thing that we have is with respect to the components, is that we onboard a device. So now, so sure. So the device that we have, when we actually onboard the device, so now there are different protocols based on which a device will be onboarded. There will be different mechanisms through which the device will communicate to the environment at which we will collaborate all the data, will push in the data from the device, we will get the data, or the device will push in the data to the system. The system will always rely on the cloud. Now the cloud is probably is a broader perspective. It does not necessarily mean a specific player. It can be a local storage, or it can be a global storage. But when I say local storage, that means it might be very explicit for that organization, or it might be very explicit for that specific enterprise. Now, that's one possibility. The other possibility is that the device might actually be onboarded, and it might be sending the information periodically, or in the form of some sequential flow, to manage that, to ensure that in what sequence the information is actually being sent. That's what the gateway acts as, a bridge in between the device or the asset and the cloud. So either is a possibility the gateway might reside on the cloud, or there's a possibility that these might be two different entities. Now, this is the first and the foremost architecture. This is the minimum architecture that you can have in cloud. Then probably generalizing and organizing what kind of data we have and how we can play around with that data, what relevant information we can get out of that information. That's where we will run analytics, or we'll run different kinds of algorithms on top of that. Now, in IoT, you will find all kinds of protocols. There you can have different communication protocols. You can have proprietary protocols. You can have very specific protocols. You will have very low-level protocols. If we talk from communicating or getting some information from the device, there can be a communication that can happen through a low-level protocol, as low as through an RFID radio frequency, or there is a possibility the device might be strong enough or sophisticated enough that it might send the information directly to the cloud through wireless, or through any of the LAN informations. Now, the communication of this architecture, this is probably more of a reference architecture, so there can be a lot of ins and outs for this architecture. So you might not actually be you might not have all these components with respect to the architecture. So I don't think we should talk about this right now, so let's not. So now this is an overview of Azure. We'll move on to AWS. Now, with respect to AWS, AWS is probably the most popular uh, uh, is the most popular uh, platform for IoT right now, because AWS has been growing very stable over the recent times. So every device will be onboarded. So every device conventionally has a specific firmware that defines, or that ensures how to pull out the information from the device and how to push that information using a specific communication or network transport protocol to send that information to the gateway or the cloud, depending how the communication happens. Now, that's why you'll see this device SDK now, because most of these IoT platforms have their own SDKs written in supporting different languages, that we can go and we can write down on the firmware of our actual hardware, to make sure that we're able to accumulate the information using that firmware. Now, this is the foremost expectation, and then probably validating, verifying that if this is an authenticated device, or if this is a malicious device, to ensure, and then probably push something or get something from the device. Even though most of the times you will find in IoT the device is always only the senders. It's a very rare site that you will find a receiver. Obviously, there are some explicit cases wherein you will expect the device to be a receiver as well, but most of the times it's only the producer. So it pushes the information to the gateway. Now, the protocols that can vary. So you can have different kinds of protocols. Most of the times, there's a very common protocol like MQTT, the messaging transfer protocols. So that is used to send lightweight messages across low-level devices. So the communications, the frequency and the communication will be very low and very thin. So that to ensure that there is lesser network latency across the device to send the information to the gateway. And then probably with respect to the gateway, there might be different components that actually come in place. Now, to onboard the device, that's where the AWS RTOS comes in place, that ensures that the device is actually onboarded. Now, the RTOS always interacts with the Amazon's Greengrass. The Greengrass works on the background of AWS RTOS that defines the integration for registering the device and getting the information from the device, and then onboarding that and pushing the information to the gateway. That's where the IoT core comes in place in AWS. The communication can be used, can happen directly through MQTT, any of the MQTT layers, or we can use AWS Kinesis for that. So most of the times, obviously, AWS supports Kinesis because it's their own proprietary protocol. So they push the information through Kinesis, and then we can accumulate the information on top of that. So we can have define our own AWS lambdas to devise some of the basic business logic on top of that. Now that is how the architecture goes. So we can actually skip this. Now, with respect to, before I move on to actually the case studies, so before I move on to the Q&A, so I would like to give you an insight of the case studies. For example, see, I will give you a very simple case study that I've actually used. So, for example, in the manufacturing domain, let's take a dummy example of any of the providers. For example, something like let's say probably something like a car manufacturer like Volkswagen. So in Volkswagen, they have the cars. So now the cars, they can sell a car in India, they can sell a car in US. Now in US, they can sell a car at any place or any point of time. Now when you sell the car, they just want to make sure that the car has some specific inputs with it, and at every point of time we're able to do a timely service. The system automatically sends an information to the buyers, or to the owners, that this machine or this car is expecting a service, and your nearest system or your nearest service station is probably 20 miles or 1 mile around, and this is the information for that service. And then this system automatically decides, probably for the first 2 years, if the car has not been driven more than 50,000 miles, then it decides that, okay, this is a free service. So how many set of free services are entitled there, how many services will actually be defined. So based on that, we identify this is a simple predictive service to alert. And then probably similar to this, we can decide that, for example, let's say a service is actually being deregistered, or probably a car was stolen. So to track the car, to identify that what is the exact location of the car right now, to get the picture of that car. So that's another possibility, to get the exact location, get the exact latitude and longitudes for identifying, locating the car from in there. That's another perspective. The firmware on the device that has been embedded somewhere in the mesh on the car will actually give us the exact accurate information about how the car is. Or the third possibility is to remotely disable the car. So in case of theft or an unauthorized access to the car will start, and probably it will start stop back after probably moving on 10 feet, or probably as soon as you try to start the car, probably just few seconds after that. So that's another possible case that we can have. I've actually worked on two of these possibilities. So this, something like this actually happens, and a lot of car manufacturers are actually working on this. Some of them are already applicable in some of the high end systems, but it's still ongoing in the process. Similarly, in the healthcare domain, wherein, for example, we have different systems that are actually working, that ensure that we try to build the systems. For example, we have an X-ray machine. We just want to make sure that after how many number of X-rays a service should be entitled for that. So a service uh, a service due automatically comes to a provider, probably a service provider's the nearest service provider in that core area. He automatically gets a message that there's a service due alert. There's a service due for this X-ray machine in this specific hospitals. Kindly go and get the service done. Now to identify, now for him to make sure that at what point of time he goes without any manual intervention. That's another feasibility, avoiding the manual intervention. So what we can do is, based on how that machine is being used during the day, probably, for example, that machine is being used extensively from 10 a.m. to 3 p.m. So now for the service guy to come in to repair the machine, to get the service done, it doesn't make sense that he comes in at probably 10 a.m. or somewhere in between 10 to 3. A good, the perfect support of IoT would be to send the service guy after 3 p.m. so that it doesn't affect, or even if the impact is as minimal as possible. That's another possibility. This is something that is actually happening in one of these systems I had worked few years ago. So even though I did not work extensively on that, but this is something that's actually a real-time scenario or case study that has actually been deployed using on AWS IoT and some of the private network for a very prominent healthcare system in Europe. All right, so I think we will stop here. We've already passed on probably around 12 or 13 additional minutes. I'm sorry if I missed anything, or we couldn't extend it more. So, but thank you again for everyone.